Oh, my baby boy. Yes, today we are talking about this night. It's close to 10 p.m. in the night here. I've had very many people asking me about sea breeze and land breeze and cyclones. Sea breeze, land breeze, and cyclones. That is not good. I want to use that one. I think this one is dead, so this is a cyclone. Jesus. Is it better here? Yes. Yes, what is a sea breeze, land breeze, and cyclone? Now, I'm beginning with sea breeze. Oh, it is supposed to be sea. Good, sea breeze. Now, we are beginning with sea breeze. How does a sea breeze take place? Before we see how a sea breeze takes place, how land breeze takes place, how a cyclone takes place, this is what we must know. We must understand the following. Convection. What is convection? Convection, in simple terms, this is heat transfer. The mechanism by which heat transfer happens in liquids and gases. Mechanism of heat transfer through liquids and gases. Now here we are dealing with gases. For convection to take place, there must be what we call convectional currents. Convectional currents. Now, let me help you understand what convectional currents are. Let's assume we are boiling water. And we apply here heat. Now, inside here is our water. We are assuming inside here is our water. The water in the first section, let's have section 1. This is first section. Then this is second section, or third section. Second section, third section. Don't ask me for the first section. Water in the second section gets heated faster. Now, when this water gets heated faster, it loses weight. The heat makes water molecules in this second section, this one, to become light. As water gets heated, it becomes light. And once it becomes light, the molecules in this water, next the source of heat, will become light. Molecules will become become light. In simple terms, the molecules here become less dense. Now, because they have become less dense, they move up. Whatever becomes less dense moves up. So we shall see the molecules here. We shall see molecules. The molecules here moving up. As they move up, they will be replaced by molecules from this section, from upper section. The last molecules here are moving up. Their positions are being replaced by molecules which are up. Now this movement, whereby molecules that are light are moving up and being replaced by denser molecules, from the topmost part of the water section, we call this movement convectional movement. Convectional movement. Convectional movement. Now, let me give you scenarios where we can understand better convectional movement apart from boiling water. Let's assume this is a kitchen, and then the top of the kitchen is what we call a chimney. Now on this chimney, this is a chimney on the kitchen. This is chimney. We're using the designs of a kitchen. Now cooking takes place inside here. Now, this is the window. Now, what happens exactly? Fresh air will enter the kitchen through the window. This is fresh air entering. Fresh air. Fresh air entering. When it enters, possibly it has oxygen, then the cooking takes place inside there, and smoke is produced. Now, smoke is residence. But at this point, the cooking is taking place at the lower section here. Cooking is taking place here. When smoke is produced, it will have to move up. Why? It becomes residence. Smoke is residence. So it moves up. And it's going to be replaced by the fresh air that enters. So this movement, whereby less dense molecules move upwards and their positions are replaced by more dense molecules. Fresh air has denser molecules. This movement is called convectional movement. So, we use the word current because the movement takes place in liquids and gases. the movement of mass liquid or mass gases, we call it current technically. So because it is by convection, the whole thing becomes convectional currents. Now, the same thing takes place on land, the same thing takes place in the sea. Let me teach you what happens during the day and what happens during the night. We believe that there is air in soil and there is air in water. We are beginning with sea breeze. Sea breeze takes place during the day. We are starting with sea breeze. Now, during the day, here is the sun. The sun, of course, produces heat. Now let's assume that this is our sea. And this is the water body. Then this is land. Now, during the day, that's when we experience the sun. Heat from the sun reaches water body. And of course, heat reaches the land. But water gets heated faster than land. Water gets heated faster than land. So, when water gets heated faster than land, air we have to come up. Now this is vapor. Vapor from water body. This is vapor from water body. Now, this water vapor goes up because the land gets heated later. The air from the land comes up, but not as fast as air from water body. So there is movement of this dense air from the land towards the water body to replace the position of this air in form of vapor that has left the sea. So the cooler air will move towards the water body as this lighter air is moving up into the space. So the cooler air replaces this space, and this lighter air also comes this side to replace this space at a later moment. We call this one sea breeze. It takes place during the day when there is sun. Now, during the night, let's see what takes place during the night. Now, during the night, at night, remember we have our land and our sea. This is sea, this is land. During the night, uh, the sea becomes colder faster, gets colder faster. Now, this means that air here is cooler. This air gets cooler faster than air here. Now, the air here, because of the heat during the day, is still light. Now, what does it mean? This cooler air will move and occupy the space of this lighter air that is on land. This one gets cooled, but at a slower rate. So its air is lighter than the air from the sea during the night. And we call this one land breeze. It's simple. This is what land breeze is. Now, should this happen in such a way that should the sea breeze and land breeze should the sea breeze and land breeze take place at the same time? Should the sea breeze and land breeze take place at the same time, caused by different factors? One, it may have rained, or it's about to rain, so one area gets cooled faster. Like the natural science here takes place at the same time. For example, sea breeze and land breeze taking place during the day, whereby we are having air leaving the sea and we are having air leaving the land at the same time. When these two air masses meet, we shall see the two air masses fighting. We shall see air fighting with another, and we shall get such a thing, a blowing. This wind is coming from this side, and another wind is coming from this side. When they meet, there is a force from this side, a force from this side. So if you happen to be at this position, you get issues. This is what we call a cyclone. A cyclone. Someone asks, what causes sea breeze? What causes land breeze? What causes a cyclone? What causes sea breeze? You have seen the movement of lighter air from the sea. From the sea. The movement of cooler air from the land to replace the lighter air in the sea. Air has to move from an area of high atmospheric pressure to area of low atmospheric pressure. Now, for example, when this air here around the land, let me do this. It's a good song. Now, this is land. This is sea. Let's see. During the day, when there is the sun, this one gets heated faster. So, this air goes up, becomes lighter. when it becomes lighter, here is low atmospheric pressure. Now, air here moves this side to occupy the area with low pressure. Simple science. People will always move from an area of high pressure to low pressure. The same applies to air. Here is high pressure. Here is low pressure. So air is leaving a place with high pressure to occupy the area with low pressure. The same happens during night. During the night, air will escape from oh, this is the sun. This is where this is land breeze. This happens at night. Yeah, good. During the day, it is the opposite. So when you ask what's called the sea breeze, simple terms, difference in atmospheric pressure. Air is always going from high, the places with high atmospheric pressure, places with low atmospheric pressure. So the difference makes air mass shift from an area of high pressure to an area of low pressure. The reverse is true. Should the two happen at the same time and air move toward the same direction, air from the sea hoping there is low pressure here, air from land hoping for low pressure here, the meeting of these two air masses causes a cyclone. A cyclone, very destructive wind. Yes, as simple as that. Thank you very much for watching. You can like my YouTube channel and subscribe. Please. This is for us all. And it's better for the country, better for the world, better for everyone.